Welcome to In 5 Minutes. In this video clip, we will discuss few numericals on amplitude modulation. Let us go to the first one. The question says, consider AM double sideband full carrier system. In this case, AM DSB-FC envelope is given with maximum and minimum values. So envelope has Vmax, the maximum value, equal to 20 volts, and Vmin, minimum value, is equal to 4 volts. The question is find peak amplitude of carrier. That means Vc is what we have to find. Modulation coefficient and percentage modulation. So we have to find out small m, which is nothing but Vm by Vc. And when I express m in percentage, we call it percentage modulation. We have to also find out peak amplitude of upper and lower side frequencies. So let's discuss the solution for this question. Let's try to understand what are the values that are given to us. When I say that envelope has maximum and minimum value, that simply means that in the double sideband AM signal that we have, so in between these two dotted envelopes, we will have my sinusoidal signal present. So now when I say that Vmax is 20 and Vmin is 4 volts, this simply means that Vmax is nothing but this maximum amplitude from x-axis to the peak of the envelope. So this is nothing but Vmax, and Vmax is given to be 20 volts, and Vmin is nothing but this minimum amplitude from x-axis to the smallest amplitude of the envelope. This is nothing but Vmin. Apart from that, we already know that this shift in the envelope is always equal to Vc, and whatever extra shift that we provide, that means whatever is that extra value to which envelope will go to, that means starting from Vc, whatever maximum value it will go to is always equal to Vm. So from this we have a relationship between Vmax, Vmin, Vm, Vc is that Vmax is nothing but Vm plus Vc, and Vmax is nothing but Vc plus Vm, and Vmin is nothing but Vc minus Vm. So now when I say that I have to find the value of Vc and then modulation index m, you can easily make out that. So from these two equations, I can obtain Vc by adding the two equations. So Vc will become Vmax plus Vmin divided by 2. That means add the two values, maximum, minimum, and divide by 2. That will give me 20 plus 4 upon 2, which will be 12 volts. I can also find peak amplitude of the modulating signal. Even though it is not asked, we can find it. All I have to do is subtract Vmin from Vmax, and that will give you, Vc will cancel out, it will become 2 Vm, so it will be Vmax minus Vmin by 2. So how much will be Vm in that case? It will be 20 minus 4 upon 2, so that will be equal to 8 volts. So we have got both the values. Even though only Vc was asked, we have obtained Vc as well as Vm. So that's my first answer. Next question says find the value of modulation index and its percentage value. M is nothing but Vm by Vc. Vm is 8 and Vc is 12. So the value of m that we get is nothing but 0.667 here. And if you find out modulation index in percentage, it's nothing but Vm by Vc into 100. So it becomes 66.7%. The next thing that we have to find is the peak amplitude of upper and lower sideband. To understand this, you'll have to recall the expression of AM signal. We have written AM signal as Vc cos omega ct plus, the next part was nothing but mvc by 2 into cos of omega c plus omega mt plus mvc by 2 into cos of omega c minus omega mt. So here this is my carrier signal and this is upper sideband frequency, this is lower sideband frequency. As you can see, both these cosine terms have the peak amplitude equal to mvc by 2. So the next question which says find the peak amplitude of upper and lower sideband, all we have to find is the value of mvc by 2. Both upper and lower sideband will have the same peak amplitude. So m that we have got is 0.667, but that was also equal to 2 by 3. So we will use that value of 2 by 3 into VC, we got carrier amplitude as 12 volts, and this will be divided by 2, so into half, and this will come out to be, this is 4, so it's 8 by 2, which is 4 volts. So both the side bands will have the peak amplitude of 4 volts. So that's one very simple question, which was mainly based on finding the various peak amplitudes and modulation index.